All right, here we go, back. Your professor, Mr. Boone, back here with 6-6. Now, before we hit our break, we actually did do some of this, but it's probably been a while, so certainly meriting a refresher on this. Now, remember when we did a couple things in this section is that when we give the roots, -1, 1, and 2, we want to write the simplest polynomial. So the way to do that is to put those back into factors. Now remember, if if -1 is a root, that means it came from the factor x plus 1, because if I put -1 in for x, that makes that 0. Well then, if it's +1, that would be x minus 1. And then another root of 2 would be x minus 2. Okay, so yeah, is it the opposite? Yeah, that's what it is. So now what we have to do is just FOIL, distribute these out. Whenever you have ones that are the same but opposite, always target those first, because you'll see what happens here. We're going to take x times x, which is x squared, x times -1, which is negative x, and then we go 1 times x, which is positive x, and 1 times -1 is -1. All right, now what happens here when we simplify is you notice those two cancel each other out, and so what we're just left with is x squared minus 1. And so now we're going to multiply that by the x minus 2. Okay, anytime that you have this, remember that difference of two squares, that's usually what happens with that, is we get those middle terms to cancel out. That's a good thing. It gives us less terms to multiply. So now we just distribute this. We get x times x squared times x is x to the third. X times -2 is -2x squared. -1 times x is -x. And -1 times -2 is +2. This is the simplest version of a polynomial that has those roots. Obviously, we could multiply through by numbers to get different ones, but that's the simplest version. And that's how you do. Okay, so when you do the worksheet 6-6, that's going to be the first two problems. Try those. The key is provided. So check your answer, and if you're not sure of something, that's a good time to email me, and we can see if we can work something out. But hopefully you can follow through, practice those as we do those, okay? And then don't do 3 and 4, because those have some other ones in there that we're not going to test you. A little more difficult there. So that's the first thing we're doing today. All right, the next thing is we're going to find all of the roots. All right. So now we have x to the 4th minus 81. Now as we know, the degree is 4. That indicates that there should be 4 roots. Now it doesn't mean that they're all real. Okay, so what you want to do first is you want to graph to find the real roots. Now our friend Desmos is certainly a great tool to use. And again, as we click on that, there it is. So we type it in, we graph it. Now we can see here we were maybe thinking there could be 4, but there's only 2 real roots. And if we click on those, we see that those are indeed -3 and 3. All right, so there we go. Those are the real ones. That's what we're going to do first. Find those first. Desmos, nice tool. You can use graphing calculator as well. Desmos is as good as anything. So right now I know that x is going to be 3 and -3. Well, what that means is that we should have 4, so that means there's going to be 2 imaginary roots. So how do we do that? Well, remember our synthetic division. We're going to take in the magic box, we're going to put either one of those numbers in. It doesn't matter. You can put whatever you want, whichever one you want. I'm a positive guy, so I like to start with the positives. There's the 3. And then remember our synthetic division. We're going to start at the x to the 4th. Its coefficient is 1. Now remember, we're missing the x to the 3rd, x squared, and x. So we have to put a 0x to the 3rd, a 0x squared, and a 0x, and then a -81. All right. Now we're going to synthetically divide that out, and we know that what should happen is we know 3 is a factor, so which should divide it equally. We know we should get a 0 in the remainder box if we do it correctly. All right, so we drop the 1 like it's hot. We take 3 times 1, which is 3. We add those together to get 3. 3 times 3 is 9. We add those together, 9. 3 times 9 is 27. If we add those together, we get 27 here. And 3 times 27 is 81, which of course confirms that yes, we did do this correctly because our remainder is 0. Now by dividing that out, we have gone from a 4th degree, a quartic, to a 3rd degree, a cubic. So we're gonna divide again. This time we're going to put the -3. This time we're going to use these coefficients, 1, 3, 9, and 27. Now once again, we should get a 0 for the remainder because it's a factor and should divide it equally. Let's see what happens. Drop the 1 like it's hot. -3 times 1 is -3. Adding those together gives us 0. -3 times 0 is 0. Add those together, you get 9. And -3 times 9 is -27, giving us the remainder of 0. And that's what we always want to do, is get it down to a quadratic. And what happens here is we have this quadratic. Remember, with that, what this means is that we have, this is the x squared, this is the x, and this is the constant. So what we have is we have x squared plus 9. We want to know what makes that 0. So, x squared equals negative 9. X would be plus or minus the square root of negative 9, which we know is positive or negative 3i. We know those always come together in pairs. So we have those roots that we have are the two real ones, 3 and negative 3. And then we also have 3i and negative 3i. And if you want to write it as plus or minus 3i, that's okay. They always come in pairs anyway. So those are the 4 roots that we get. All right, so there's some ones in the middle there. The worksheet 6.6, give those a shot. Key is provided. Check those along with what you got there. Questions, again, let me know. But that's 6.6. All right, enjoy, have some fun. We'll do 6.7 next, and we'll see you next time.